we definitely, I definitely want to have you back on in the future. And then, you know, we also have in the evenings, we also have experimental stuff. So if you're building experiments,
well, when I build my next aluminum wire coil, and I'll make a video of it and share with it. Like, you know, I think you have so many brilliant people in your group. I think with all of us together, we could build some pretty incredible experiments, and we can have this technology with the materials that we have.
Well, and Mark Sokol has an entire group of people. He's got a team of people building stuff. He's got a, you know, a lab that they've set up and all sorts of stuff. So he would be the person to work with on stuff like
well,
that.
I gotta watch. Send me the top, you know, 10 videos to watch, and I stay up late at night when my kids are asleep, and I watch these presentations. I want to get up to speed on everything that you have, and get to know, you know, who the people who are building stuff, you know.
Okay. Well, yeah, so let's do question and answer session. So again, it's option Y on Mac or Alt Y on Windows to raise your hand to ask David questions. And again, you covered so much ground, you know. I mean, and that's why it would be wonderful to have you back to focus in on a couple of these topics. But okay, let me go to Bill Alec first, sir.
Oh, Bill Alec. Yeah, I know Bill from a long time ago.
Yeah. Yep. Oh, you know what? Sorry, this is my fault. Hang on. Allow participants to unmute themselves. Sorry. Okay, Bill, go for it, sir.
Okay, can you hear me okay?
Yep, I can now. Sorry about that.
Oh, okay. Yeah, David, great presentation. Loved it. Great source of inspiration, great experiments. Yeah, with Boyd Bushman, you know, I did replicate his magnet drop experiment, you know, with the opposing magnets. And yes, he is absolutely correct about that it does fall slower.
That's important. So important that you did that. I remember you telling me you did that back in the Sedona days when I was living in Sedona.
Right.
It's so important because it demonstrates the diamagnetic effect is producing some anti-gravity. So again,
oh yes, yeah,
the idea of building these lenses,
Now I just want to mention that I did extend that experiment using magnets, and I observed that they fell faster than the control.
That's exactly what I would expect, faster.
Yes.
And that interests me too, because of the idea of the difference between diamagnetic and paramagnetic. And if it falls faster, it means you could build a hypersonic around that idea, because that's causing in the outside envelope that you're moving through everything in the magnet to become more north-south pole aligned, which means you have less resistance to movement, which means you would go faster. So the question is, does diamagnetism go slower and paramagnetism go faster? That's what we got to figure out.
Well, you know, it seems to me that you can build a warp drive out of this.
Exactly.
Okay, out of the two concepts, you know, the Alcubierre warp drive, to get that signature of positive and negative bending of space-time using magnet and...
See, that's exactly what I would expect, Bill. One of them goes faster, and it's probably the paramagnetism that goes faster. And that, God, there's so much you can do with this. You can do it step by step. You can first build hypersonics with traditional thrust, and then as this lensing idea gets more powerful, you may see real anti-gravity where you don't need traditional thrust. Again, what you're moving through and the alignment of the magnetic poles and your magnetic moments is where the problem is. And that's why we're wasting energy, because you're pushing against that envelope. Inside of the Earth's atmosphere, it's oxygen and nitrogen, and those, you always see the pairs, paramagnetic, diamagnetic, in your background. In the space environment, of course, when you get near planets and other stars, everything changes in the space between, you know, what is the background made of and what are the magnetic alignments. And so in a way, a stargate, when you create a coil with a vortex in the middle, that's why you're starting to see some of these incredible effects in the Rodin coils too. I mean, I met Marco Rodin in person, and he said, I don't make coils. People call them Rodin coils, but they're making coils based on my math. And the star coils do the same thing in the middle. There's, again, the material that the wire is made out of matters a lot. It matters a lot. I think we need to get into manufacturing some pretty exotic wire to make emitters out of. But that's important what you just shared.
Mhm.
One accelerated and one deaccelerated. That's exactly what I would think.
Yes. And the other thing, do you think there's a correlation with what you're doing with Townsend Brown at all?
T. Townsend Brown. I haven't looked at his stuff in a long time, so you'd have to be really specific on what when I saw the presentation by Sarfati, he started getting into, because I was a physics student when I was young, and I wrote a paper on time dilation, and that's when you get into my galaxy clock. It's very clear. Like, imagine if electromagnetism was instantaneous. So if you use action at a distance, everything would be straight and square and angular lines. But because time has a delay, you get the warping or the curvature of the background of space. And that's caused by what I call real-time seconds. And real-time seconds are bonded to each other through action at a distance. And those real-time seconds are not the same as our seconds. So when we measure time as a value, it's a human-made value. But if you use what are called real-time value, then you'll see there's a force that causes the warping of space-time, and that is the back end of the electromagnetic force. So if T. Townsend Brown was on to that, I have a real geometrical model that I would present next time. That because I have to spend a lot of time on that.
One other thing about that is that I was listening to this. There was another show, I think it was on rents.com. Herbert Dorsey spoke about Townsend's work, and he said he tested it in the water, his disc or whatever he was doing there. And he mentioned that part of the water would drag along with the disc. So in other words, the bow or the gravity field would extend beyond the disc a little bit, and that the real bow of the ship would also include some of the water as well.
I would expect that, right? Because your water is hydrogen and O2, so you got paramagnetic and diamagnetic again. But once you build a diamagnetic, the paramagnetic materials will move around it. They'll mimic it, so that they'll do exactly what you're talking about. And that's why I think the Navy sonar data is showing these UAPs moving 12 times faster or even faster than that in some data than our fastest submarines, right? Because exactly like you just described. I think you're looking at paramagnetic and diamagnetic envelope. See, again, the angle of that lens, whether it bounces, if I have that's why we need real data. Like if I have a very steep curvature, then I'm going to have my focal point's going to be exactly the opposite, diametrically opposite side of the inside of the envelope. And maybe that's important. Or if it extends beyond the envelope, then my focal point, it's going to, remember, I want my material to be the highest diamagnetism and the highest paramagnetism possible. And like you just said, it looks like paramagnetism moves faster. And I think both experiments have to be built, and then you have to study the angle of the inside of your parabola. Yeah.
Awesome. Well, so let me just jump in real quick. So again, option Y on Mac or Alt Y on Windows to raise your hand to ask Mr. David Sereda a question. David, what you just mentioned about the undersea objects, that's really, for me, that's really interesting. I think it seems like that's probably one of the biggest up and coming issues when you're talking about UFOs or UAPs. It's something where it's the impression that I get is it's like we've seen the tip of the iceberg and there's a whole lot more there. I have no idea what, but it's something I think actually, the military just renamed, right? They just renamed their organization to the All Domain Anomaly Office. I think they are starting to pick up on that as well, right? It's this connection with the ocean, and it's not only are these things in the air, but they're also the sea, and we just didn't have the visibility on them we had before.
They go so far back. I mean, I think the biggest military mistake is to give the Chinese and the Russians air superiority, because you're handing them over credit for having air superiority, and that's a mistake, because the performance of these things and the sightings of these things go so far back. It's very unlikely they have it, and if they had it, they would exercise it over us, and they're not. So when I see this in the media giving China credit, that's stupid. I mean, if anything, I would have given the U.S. military credit, even if I was bluffing, scare the crap out of everybody else.
This is just my personal opinion, but it's UFOs have such a tremendous stigma, and they have for many years, right? And I understand why that is. Part of it is you have had so many just complete people who were just, I don't know what you call them. You've had so many non-credible people. I mean, and this goes back 70 something years. I mean, there was, you've got Heaven's Gate, you've got, there was a cult that thought they were UFOs were from Venus. You had people who thought they were from Mars, just all sorts of wacky stuff. And so I think from the military and Congress and all of those, I think that they're invoking foreign powers as a way to try and say, well, look, we don't know what it is. We want to talk about it. We want to deal with it. Let's try and frame this in something that's not, you know what I mean? They're trying to put some
distance. I think what Gary Nolan said about the Italians, and they're not, I think on the inside, the other side knows it's not them. And I think they know that we know it's not them. They're just playing the public, maybe for a motive to build our defenses up higher against Russia or China. I mean, if these things were to reveal themselves right now, if we were to demonstrate the possible use of a nuclear weapon right now and they intervened, then maybe Russia would just stop and back down and realize there's another force at play here. And that both Gary Nolan gave us clear evidence of that, and so did Jack Sarfati, that our navies know they have bases under, like, let's I go back to Roswell. Let's go to the beginning of Roswell, because Roswell starts in Idaho when this United Airlines pilot sees these UFOs. Then it goes to Kenneth Arnold sighting in June, and then it goes to Portland, Oregon on July 4th.
Actually, if let me rewind you a little bit more. So I found sightings as far back as Hanford in 1945. Real encounters, and this is the nuclear production related stuff.
Right. I think there's a connection there. Like, I believe when we detonated Trinity, it's the gamma. So in the film Terror in the Sky, with these very advanced flare cameras, they're seeing these gamma spikes of around 45 million electron volt or mega electron volt charges. So when you detonated Trinity, there was a huge gamma burst, which may tear that fabric open. The fabric that I'm talking about is the background, the spaghetti, and it may cause a temporary tear where they come through. And then notice how all the incidents in Roswell are within a few days of Trinity, a few years later. Or was it 1 year, 1945, 1947, 2 years later? But the crashes are all around Trinity. And it was either Sarfati or Gary Nolan that in the interview on Tucker Carlson mentioned that they saw UFOs right during Trinity, right? And that would have been the moment they came through. So you have time dilation. When you understand time dilation, and Sarfati understands that, I understand time dilation, then then what you realize is there another step where you need a gamma emitter inside of this lens? Because Hutchison's using static, RF, X-rays. Now, tungsten is used to, it will trap gammas. It's the only metal, that and lead is the only metal can do it. But tungsten actually works better. I bought myself one of these tungsten containers. It's this big. It's like 40 pounds, this little thing. And they use it to put, nuclear materials in so that they can transport it around without the gammas affecting anybody, right? So you're talking about maybe your emitter on the inside needs to have these 3 or 4 tiers, and maybe gammas. See, here's what happens in a wave trap, is if I trap a radio wave or I even trap electron, it will create a quantum tunneling event and burn a hole through the wall and jump out the other side of the wall. But the moment you have a quantum tunneling event, you have a portal that is immensely powerful. So you can't trap a wave, it will quantum tunnel through the other wall. So if I put gammas inside of my wave trap envelope and I do a gamma burst, maybe that's how they jump into hyperspace, is because and that's why we see evidence on these flare cams, and that's in Terror in the Sky, of these quick gamma bursts. Gammas are powerful, immensely powerful. So that may be what they're doing. So there's one aspect is where you're anti-gravitic and you can move around. And once you've canceled out most of your inertia, the amount of energy it takes to move around is tiny. A couple of volts and you're flying, right? And that explains why you don't see these massive, you don't see a shock wave behind the UFO. So if the Tic Tac is down here and suddenly accelerates upward with traditional propulsion, the shock wave would create an explosion in the water behind it. It would disturb everything behind it. And the pilot, the G-forces will kill him, like you were saying, Tim. I heard you say that. We know that. So that means that that's not how they're doing it. And if you don't see evidence of massive propulsion thrust, they're doing it, but was a way more likely what I'm talking about through the magnetic lensing.
Well, yeah, no, you bring up an excellent point, right? I mean, the reported performance of these things, and I think it's easy for all of us to lose sight of that. But yeah, these things it's not a vacuum. These things are doing it in air and water, and then they're going from air to water, and so that's there's you just can't do.
And this kid did it with an aluminum envelope. So again, there's so many kinds of aluminum, and that's why, what kind of aluminum did they have in 1947 in Los Angeles? Like or was it an alloy? Did it have titanium in it? Like there's a lot of questions there. Does it have to be a paramagnetic and magnetic mixture? And so that when you do experimentation, you're going to spend a lot of money. You can do a lot of things that don't work. But
sorry, I see your baby behind you.
My daughter. Sorry.
Yeah. Oh no, that's cool. Hey, again, we're the Super Mellow Conference. So
yeah.
You know what? Let me go to Michael Boyd, who's patiently had his hand up. Sir?
Can you hear me okay?
Yep. Michael, welcome back, sir.
Thanks. Hey David, I have
Michael.
Questions. First, at one point you mentioned that gravity propagates at the speed of light, and I'm curious what evidence you have for that.
Well, that's the traditional calculation is that gravity travels. No, I don't think that's true in all cases. It's the same thing. Light can go faster than light. In fact, Tesla's alternating current radio went nearly 1.618 times the speed of light. Velocity.
Well, I don't. So, are you talking about the there's like a
velocity. LEGO scientists and NASA, the speed of
packet itself is moving faster than light, but within the wave packet, there's other waves that are at the speed of light. Is that what you're talking about?
Well, yeah. So I think it's the same thing with light. Light will travel faster than light. I mean, you go into faster than light ideas. If you go to Dirac, like let's start with the Big Bang for a second. So the idea of that. that there really is no bang, because there's no resistance in the beginning. Because if we start at a sea of negativity, all of the CMB, the cosmic microwave background radiation, distributed itself instantly. And as the universe builds more and more polarity charges, your resistance value goes up and your speed of light slows down. And then time appears. So your time value is 0. Your mass energy value is 0. And so according to Dirac, what we think is a big bang, there's no bang because there's no resistance yet. So it's instantaneous distribution of the CMB. And then as the soup gets denser, the light slows down, and then it appears that the universe is 14 or 18 billion years old, because you do a calculation backwards in time. But it may not even be that old at all, because if you study these faster than light theories, as an evolution, the speed of light, if you go to your refractive indexes, for example, water slows the speed of light down by 20-something%, right? Diamond slows it down, a lot. So you have all these variables.
What you're suggesting then is that the speed of light depends on the medium it's traveling in, correct?
Yeah, exactly. And that charge on your background, all your magnetic polarities and whatever your background is, if they're not coherent. So faster than light, like for example, Raymond Chow at Berkeley, and I spoke to Raymond Chow personally about his experiments. It was published that he sent coherent lasers through glass, silica, quartz, which is a tetrahedron, which will cause the light to compress and focus. He was going 3 times the speed of light, and Chow said he doesn't know why it's happening, but it's happening, right? So there's certain materials that light will go faster through, and then there are certain materials due to refractive index it will slow down, right? Like water slows.
So are you saying gravitation is an electromagnetic phenomenon?
I believe it is. Now, Einstein was approached by a student with that idea and he rejected him. But I think, and if you listen to Sarfati's lecture, he's getting into, actually, I found this on his website. So you read the article on his website, they're a function of each other, right? They have they have functions of each other.
So you mentioned quantum tunneling.
Quantum tunneling.
Yeah, and I've worked
So here it is. Gravity moves at 299, 792, 458 meters per second. That's standard knowledge, but that doesn't mean all gravity.
Again, what evidence do you have to support that?
No, I'm not saying I agree with it. I don't agree that the speed of light is constant either. Okay,
so let's talk a little about quantum tunneling. So I worked on quantum tunneling in the 80s and 90s. What it is there's a certain kind of semiconductor junction. It's called a Schottky diode. And essentially what it does is it lets you set up electrons on of opposite spins on both sides of the junction, the middle part, and they're entangled with each other. So if you change the effective spin on one side of it, it immediately affects the spin on the other side. And so and they've actually did a lot of experiments and found that the information is traveling across the gap at faster than the speed of light. So now that's an example of faster than the speed of light, wouldn't you?
Right, and there was an experiment done with beryllium where they had a quantum tunneling event occur where it wasn't photons. I think it was, I don't even think it was an electron that quantum tunneled. Now, beryllium, the speed of sound in beryllium is the fastest of any metal. It's way faster than aluminum. Beryllium really interests me, of course, which is, I mean, this is an aquamarine, right? So it's a beryllium gem. So beryllium the experiment that was done, I read this in a physics article about a quantum tunneling event in beryllium, and you might be the person to really get to the bottom of
So
that.
beryllium is used in infrared technology for what's called an IR tran material. So like on your cell phone, for example, it has a near infrared. It can go out to 1.1 micron because that's where the glass cuts off. So basically, as you go out in the infrared, glass becomes opaque and won't transmit the IR. Okay, and beryllium's like that, but it goes out farther. It goes out to like 4 or 5 microns. So it's transparent to a wider width. So it's actually used. And now they do, I don't think they've made any semiconductor junctions out of a beryllium, but I do know that, like I said, that it's used for infrared windows.
Well, I think Bob Lazar was playing with some beryllium balls. I asked him about it because Magwitch told me, if you get beryllium dust in your lungs, you're going to get cancer. And so your beryllium is diamagnetic. So there you go. So remember, your diamagnetic. I don't know how high on the diamagnetic list it is. But, you know, properties of materials studies done at Bell Labs. I've read these very old physics volumes from the Bell Lab experiments. They got data in those experiments that they didn't even know what to do with. Those are really worth studying.
What do you mean, Bell Labs? Are you talking about the development of the transistor? Is that what you're talking
about? No, not just the transistor. I mean, I had volumes, old dusty volumes that were printed way back in the Bell Lab days. They did all kinds of experiments there, and they were just collecting data on the properties, hidden properties of materials. But once they got the data, I mean, for example, I read this in the volume on molybdenum, that it was the best photoelectric converter, and eventually thin film solar made out of the same stuff performed very, very well for.
Oh yeah, you're right. I remember Cylindra. Remember those guys?
So they did these experiments, but they didn't know what to do with the data. It's like you're sitting on incredible data here. So again, every material has, of course, you go to your crystal lattice and you look at your geometry and you look at, you know, was that responsible for the faster than light signaling? And then at Princeton, they did an experiment with cesium, where they sent lasers into 4 different angles of the cesium, and it went over 400 times the speed of light. Then it became classified. That was Li-Jun Wang at Princeton, published in NBC News, but then we never saw any more of it. Like 400 times the speed of light in sending lasers through cesium. So I think it goes right down to your crystal lattice scale and the geometry, right? So again, you look at your geometries of your UFOs, you look at the geometry and the wave. If I use the proper wavelength for the inside of my cavity, I might get better performance, right? So whatever this kid did, I mean, he was a tinkerer, right? He worked at Chevron gas station in the San Fernando Valley way back then. And what J. Edgar Hoover, if you go through those FBI files, he's got all these kids building toy flying saucers. It's like a Spielberg movie. And then there's real UFOs. You know, there's the Maury Island incident. There were all these UFO waves in Washington. And then they went into, at the last, there were 8 UFOs over Edwards Air Force Base around July the 7th or the 8th, 1947. And then you have your 3 crash sites around Roswell. So there's a lot of data there. I definitely see time dilation, and I would love to talk to Sarfati, because I don't know how much longer we're going to have his brilliance, right? And I don't claim to have all the answers at all. I don't claim to have all the answers at all. I'm just saying that the collective pool of knowledge here, with enough resources, we could build some incredible experiments that are within the public domain.
So I'm curious, you're mentioning Jack, and I've read a lot of his work, and I appreciate it. But one of the things that I notice he's focusing on is what I call near field effects.
Mhm.
And in my research, like for example, in the Tic Tac, there's a lot of what are called far field effects that are observed. So time dilation is an example of where you would be able to observe these effects in the far field.
Right. Remember the picture I showed you of the Go Faster gimbal, where it in one frame it splits in two. It's not two UFOs, because it comes right back together in the next frame, and then it splits again. Like, nobody's looked at that and did calculations on wavelengths. And you think of the double slit experiment, for example. Like, again, you think of background as a fabric that we're pushing against when we're moving around. There's way more data here. There's way more data here to figure this out. Do you guys think that these Tic Tacs are somebody on Earth, or from an ancient civilization that's been living here for thousands of years? I mean,
well, my personal opinion is it's an earthling.
it's an earthling.
And
Well, that's
Yeah,
one
I think
heck-
everybody has.
And thanks for answering all my questions. I do appreciate it.
Yeah, I'm
Yeah. Let me go to Pepe. We've got about 10 minutes left. Pepe, go for
wait
it.
a second.
Sir.
I want to say one thing. It just came up, Tim, in my conscience.
Oh, sure.
Pei, who his last name is Pei. His schematics of what could be a Tic Tac. He had magnetron microwave emitters inside of a cavity, and he's claiming he got anti-gravity. So that's along the same lines as what I'm talking about. I just
Oh,
wanted
okay.
to bring that up.
I think he's talking about Salvador Pais.
Yeah, I am talking about Salvador Pais. Yeah,
Okay.
but
So-
I don't. Yeah, I think that data is consistent with what I'm saying. I don't know what his materials were, though.
Let me go to Pepe now, sir.
I thank you, Tim, and thank you, David, for excellent presentation. It's always great to hear you.
Thank you.
You keep me focused on you and the presentation. Thank you. I just wanna say that during your presentation, you mentioned that you don't know what kind of aluminum there is. And I can give you a report that may give you an insight of what you can use.
Mhm.
Chuck Wade, I don't know, you remember?
Chuck Wade gave me a sample. I have one of his samples, and you're right, it's aluminum. And I probably still have that sample in a drawer somewhere. And I did some different tests with it, exposing it to different types of energies. Again, it's not constructed. But yeah, I have a Chuck Wade sample around here somewhere.
Have you seen
It's
his report?
No, I used to have access to his report, but maybe.
I
that
put it
type
on the
of-
chat. You can look
Okay.
it at on the chat.
Okay, so that's important. Yeah, you're right. That was retrieved from Roswell.
Uh-huh.
Where is it in the chat? Is it the most recent?
No, it's the second most recent.
Analysis report of metals. Okay, let me download that.
Okay.
And then, yeah, I'll look at that. There, I
Okay.
got it. Thank you. Thank you for
So you're
that.
very welcome.
Ex-
And thank you
excellent.
for your presentation.
Chuck Wade. Yep, that's.
Awesome. Yeah, no, I mean, this is all incredibly interesting stuff. David, I would love to have you back on to present more. We'd probably want to do some focus topics, right? Like you talked about the galaxy wave map and
Well, the galaxy clock, it was
Sorry,
given to me in a apparition of Nikola Tesla, appeared to me in January. Was it the day he died? It was January the 7th. He appeared right in front of me in the middle of the day, shining like the sun, and he just flashed this model, which I'll share next time. But I think I have to get going because of my kids here. We're supposed to go somewhere.
yeah. Well,
I know
and you know what? If you want, we could wrap. Mike Brace is with us. Should we? So why don't we do this then? Why don't we wrap things up? We'll do it just a few minutes early here. So let me put this thing back on gallery view. Everyone, please give another hand to Mr. David Sereda. David, I can't thank you enough for joining us today. Thank you so much.
Thank you,
It was
Tim, for what
truly
you're
an-
doing is so important, what you're doing. And I will talk later about how to share through my marketing list and my personal list of 15,000. So I'd love to help you as much as I can.
Awesome. Awesome. Yeah, I would love to talk about that. Okay. So
Okay.
I'm going to put this back on speaker view. And so now I want to introduce, and let me mute everybody out here. Okay. And so now